Hi, everybody. Welcome to section 3.4, applications of the derivative in business and economics. So the learning objectives for this section are to use a derivative to perform marginal analysis, find inventory costs using economic order quantity, EOQ, and find the elasticity of demand. So let's go ahead and start with seeing what our textbook says about marginal analysis. So, marginal analysis is in business and economics. The word marginal is equivalent to the phrase rate of change. Okay. More precisely, it is the instantaneous rate of change. So, the marginal concept in business and economics is a derivative concept in mathematics. So that is how the derivative helps us in business and economics. So let's go ahead and read through marginal revenue. So marginal revenue is the approximate change in the revenue associated with a 1 unit change in the number of units sold. 1 unit change in the number of units sold. That means what does it cost to make the next unit, the 101st unit as such, as we've seen in the past. So it is a derivative of the revenue function, right? That means marginal revenue will look something like that. R prime of X is derivative of the revenue function. So that is what marginal revenue is, and it's pretty much copy and paste with cost and profit, the same exact definitions, how much it costs to do the next one, how much profit is the next one, right? Profit, cost to make the next one. So these are also denoted with like C prime of X and pre prime of X. Okay, just a derivative of those cost, profit, and revenue functions. So let's go ahead and apply this to an example. So example one says a retail company estimates that if it spends X thousands of dollars on advertising during the year, it will realize a profit of P of X dollars. So X is our thousands of dollars variable, and profit is what we're checking out. So here's a function, profit function, negative 0.25x squared plus 80x plus 1400, where x is between 0 and 336. Okay. The question's asking what is the company's marginal profit at the $100,000 level and $260,000 advertising levels? And then what is the advertising expenditure you would recommend to this company? So we have two questions here. Let's go ahead and focus on the first one here. What is what is the company's marginal profit at these levels? So let's go ahead and figure that out. So I need to figure out the marginal profit. So that means I got to find the derivative of this profit function. So let me go ahead and rewrite this profit function. Negative 0.25x squared plus 80x plus 1400. And I need to find the marginal profit. So that means I need to take the derivative of this. So this would be, you drop down the 2, the x goes away. That's a constant, so that goes to 0. So we negative 0.5x plus 80. Okay. So now I want to find the marginal profit at 100,000 and 260,000. But remember what X is describing, it's thousands of dollars. So I'm not going to plug in 100,000. I'm going to plug in just 100. I'm going to plug in just 260. So let's go ahead and figure what those are. So plugging in 100 into our derivative, so negative 0.5 times 100 plus 80. That ends up being negative 50 plus 80, which is just 30. So P prime of 100 equals 30. Okay. So now let's go ahead and check out 260,000. And remember, I'm just plugging in 260 because X is thousands of dollars. Okay. So plugging in 260 into our derivative, 0.5 times 260 plus 80. This ends up being negative 130 plus 80. Add those together, and that's negative 50. So P prime of 260, rewrite that, prime of 260 equals negative 50. Okay, so this means a marginal profit at 100 is 30, and the marginal profit at 260,000 is negative 50. So what does this mean? So let's put this into words. That's so the marginal profit is $30 at the $100,000 level of advertising, and it is negative $50 at the $260,000 level, oops, level of advertising. Okay, so this seems to me that at $100,000 they're making a $30 profit, and at $260 it looks like they're losing $50 per. So, okay, so that's part one, right? Now let's go ahead and check out part two. Part two asks, what advertising expenditure would you recommend to this company? Okay, so let me go ahead and split these. So what this means to me, right, this question two, what this means to me is what I would recommend is what's going to make you the most money, the max profit. So I want the max profit. And what that means is I have to find the critical value. So that means I have to take the derivative, set it equal to zero, and find that max level of advertising. So let's go ahead and check that out. So I have the derivative, just rewriting it from before, negative 0.5x plus 80. To find the critical value, right? To find that max, I need to set this equal to zero and solve for x. So I'm going to set this equal to zero. Zero equals zero, negative 0.5x plus 80. And we just got to solve for x. So I'm going to move 0.5 to both sides, right? That cancels out. So I'm going to have 0.5x plus 80, sorry, equals 80. And I'm going to divide by 0.5. That cancels out. So what I'm left with is x equals 80 divided by 0.5. So x would equal 160. Okay, so I get 160. But remember what x represents. It represents the thousands of dollars in advertising. So it's really valuable 160,000. And what does it mean in terms of the problem? So what I would say here is to maximize profit, the company should spend $160,000. Let me write that on advertising. Okay, so that's what I would recommend. Okay, so that's how you would apply marginal analysis to profit by seeing where you're making money, where you're losing money, and how to best maximize profit. And these could be applied to any type of cost, what's costing you the most money, and what's revenue, what's making you the most money. So that's it for this example. I'll see you next time. Thank you. Bye.